The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be beginning our 30 minutes of free training today. With me, as always, is Kevin Rankel. Hey, Kevin. Let me just share my proper screen.
There you go.
There it is. Okay. So today we will follow up with a request we got before we started doing the begin to end parts. And that's basically translated surface. We were asked to show how translated surface works, what it does. And for those of you who've never seen it before, it's actually the toolpath that is part of your 2.5D or even the basic package, this guy right here. Now, translated surface, because it's part of this package, you can kind of get an idea as to the history of this toolpath. This existed before we had certain toolpaths or certain functionalities that you'll see in other toolpaths. So this is the kind of thing that it's interesting how it works. You can see how it could be considered a legacy toolpath and how you would do this probably with only 2D sketches. But generally, I think the consensus amongst us on the SolidCAM tech support side is you would use other toolpaths for some of the stuff that we're about to show you today. So it's an interesting toolpath, but I would definitely say you can achieve some better toolpaths and a little easier to get those toolpaths with some of the other toolpaths that we have, like HSS, 3D engraving. A lot of the stuff you're going to see today, I would say, has been replaced, but let's go through the history of what this toolpath does. So translated surface, if I just open up the first one here, I've already pre-programmed this, is basically the idea that you take a path. So if I just show the geometry I've highlighted here, there's my path for this one feature we're about to mill here. It is essentially a 3D feature. You can see that it's just a hemispherical slot there. But what you do with this toolpath, it's very similar to the swept feature inside SolidWorks. You give it a cross section and you give it a path you want to follow. The difference here is that everything has to be completely planar. So even though that's my path, I actually don't choose this geometry here, the cross section. I actually have to copy that geometry onto a similar tool plane like you see here and choose that as my cross section geometry. So that's really the only difference between the geometry selections here and the swept geometry inside SolidWorks. You're still choosing a cross-sectional geometry, you're still choosing a path, but what we're doing here is we make it all planar. So I essentially just I made a copy of that sketch and put it onto the tool plane. I'll tell it, do I want to use that geometry as the start or the end of my chain? And then side of geometry, if we take a look at what side I have that on, so if this was my path right here, I had this on the left side. And then from the surface that will be generated, again, this is called surface offset, but we're using just chains. So the eventual surface that will be machined by this toolpath, how much material do I want to leave on that face? And that's essentially surface offset right there. So in terms of geometries, it is very simple. Now it's the execution of this that's a little complex because the section geometry that you have to choose has to be in a proper, I guess they refer to it in the help menu as like a quadrant. So when you're doing this, you're going to choose your path and then you choose your cross-sectional contour. But when you go to select it, as you saw from the training video and the KevCam video, we made sure that the reference point was right on that path. That way it's easy to select it and it's easy to understand things like depth and such. So if you have any issues with creating your translated surface toolpath, check to see where you actually have that cross section, if it's in the proper quadrant of the setup. Tool, you essentially can use any tool. I believe in the KevCam, he actually showed you which one you can add, so I'll just do that myself here, where it's these particular tools that can be used in the translated surface toolpath. Essentially anything you would use for roughing or finishing almost. You're not going to be able to use a drill here or a tap or anything like that. So it's very, very simple in that way. A lot of this functionality is going to be very similar to profile in that you're going to give it offsets, you're going to tell it left side, right side. So that same sort of methodology carries over, even though this is a somewhat of a 2.5D toolpath approximating a 3D toolpath, it still has a lot of that same sort of 2D, 2.5D methodology and nomenclature. So let's go to levels. It really only has the upper level because all the depths, all of the stuff relating to the 3D portion of this is going to be read from that cross section. So from that reference point, it's going to go down to the end of the chain there. Basically, if we look at it in the eventual toolpath, that chain represents this. It's going to go from the top to the bottom there. So I just need to tell it where the upper level is, and then it'll figure out depths and that sort of thing. So that's why we really only in terms of selection is the upper level. In technology, it's like I said a second ago, very similar to profile. I say this a lot when we do these videos, that it's very similar to something, and that's because the workflow should be the same. It makes this very easy to learn, and if there's something on here that is has the same name but you're not sure what it does, or even if in general it has a different name and you're not sure what it does, either the bottom left corner will let us know what it does, or you can click on the green check or the question mark here and then click on something, and then the help menu will pop up and show us what it does. But in this particular toolpath, a lot of the stuff is the same. You'd be able to understand this if you remember that this is very similar to almost like a three-dimensional profile. You can either tell it to do one way or zigzag. You can constrain the toolpath using a working area. Here it's just called constraint, but it's basically working area. And with limits, you can open up this tab here, and you can add a sketch that represents some sort of boss or something in the way that you want to modify your toolpath. But let's say we just do it as is right here. On the right side is the offsets and the rough versus finish parameters. So in this case, we'll just do it as a finish. If I'm doing finish type, I can give it the scallop. And this is very similar to the scallop you'll see in the HSS toolpath. This is a step along the curvature that is eventually generated here. And if we go to link, we have our lead in, lead out abilities here as well. So it's very similar to profile. If we take a look at this toolpath, you can see that it's doing the step over. And the step over, the movement of the tool is following that curvature there. So it's almost like it's just doing a profile step over, but it's following that contour that we defined in our cross section. So it's given us that kind of nice little feature there. And this is, honestly, this could be a really great toolpath to use if you didn't have HSS. Because with HSS, linear, constant Z, you can pretty much achieve the same motion here. With full HSS, you definitely can replace this with some better toolpaths. But if you only had the 2.5D package, the basic Express package, this is a great way to do this sort of feature here. And that's just the finishing portion of it. If we take a look at how you can do roughing of a 3D feature, again, it's a feature that has a cross-section and a path. So it's almost like if it was a swept feature. If we look at my original SolidWorks model in the feature tree, I think I actually used sweep to create these features here. So anytime you have that sort of constant, consistent cross-section and a path that it could follow, translated surface could be the toolpath to use. So let's take a look at that as it applies to this kind of shape here. So pretty much the exact same thing. In terms of my path, I chose that line right there. My section geometry, I took that cross section there, projected it to my tool plane, and I made sure it was in this quadrant down here, so that when I chose side from geometry right, it's on that right side. So you can almost think of it as the old third angle projection kind of glass box kind of scenario where I took that and I flipped it up. So as long as that's my reference point there, you can see that that's going to be my cross section as we go across there. And then again, surface offset set to 0. In this case, I'm using a flat end mill, so I'm roughing this out. My levels, upper level, under technology, I'm doing zigzag. I have a surface offset because I'm roughing, and I've given it my overlap, so I'm overlapping by 80% of the tool diameter, and my step down is 50 thou. If we take a look at that, it generates basically another 3D toolpath using 2D functionality, using some sketches on the tool plane. I give it step over, step down. You can see that it's generating that toolpath there. If we take a look at that in our Solid Verify,
now one benefit to doing it this way is Mark does not need a model. So remember, this is all created off of just sketches. So it kind of goes to the fact, like we were talking yesterday.
yes.
You know, if you guys are just getting that napkin sketch, this is how it can be done.
Exactly, and that's kind of why I was referring to this as kind of like a legacy toolpath. This goes back to the days when we would only have maybe just a print, and maybe you just loaded this up into a, I mean, I don't know if SolidCAM existed back in those days, but the idea that a lot of the times in those days, CAD portion of stuff was literally just print geometry. We would go from having to do things by hand and programming to code inside of a CAM software, but we're still only dealing with sketches. You can see that here where it's all driven by just sketches. There's nothing solid about this, just like Kevin said. There's no surfaces here, there's no solid here. The surface being generated here and here is just the result of this toolpath. And you can see that it did that roughing there like that. Okay, so that is really, there's the two things that this toolpath does, the roughing and the finishing, and you saw that there. But there is an additional topic in the translated surface that actually hasn't been covered in a previous KevCam or tips and tricks video. And that is if we go up to the top here, top left, engraving. So again, this probably could be replaced by the 3D engraving toolpath. This could be replaced by projection HSS. But to show you how this one works, let's go through the motions here. So again, we have our path, as you see there. We have our cross-section, same cross-section as before. So I'm basically telling it that I'd like whatever toolpath I'm about to generate to have that shape. But in terms of engraving, if we jump right ahead to technology, it's asking me for my engraving geometry, very similar to what you would see in the 3D engraving toolpath or your HSS projection. And you can see there, I have some lettering there that I've selected as my geometry. So this essentially will work like a projection. I'm basically telling it to generate a toolpath that follows that same shape. In this case, I just projected it to the curved portion, but it would have followed all of that cross-section there, and it generates a type of engraving. If we take a look at that in Solid Verify, and speed that up a little bit. There you go. So again, it's a very much of a projection of some 2D geometry. There's nothing here about surfacing or anything. I look at this as the fact that since it's not using any 3D geometry, or it's not using any surface geometry, it's purely just 2.5D planar geometries. The only time I would think of this as being useful is maybe you have a translated part where the surfaces are terrible. You have no surface you can work with, the geometry didn't translate correctly, and you're stuck with using just lines and arcs and 3D geometries. Very similar to what we talked about yesterday with the contour 5-axis in the same scenario. Maybe you're trying to generate a 5-axis toolpath where the surfaces are not helping you, you don't have any 3D geometry that'll help, and you're stuck just using sketches. Here, you could do very similar stuff that you would do with HSS that relies on surfacing, but here you're using just sketches. So it's kind of like Kevin said a second ago. It's only based off of 2D geometry, but here you can see you can generate some great 3D technologies, 3D toolpaths with only those sketches. So it's a good bridge between what you're trying to do with the old school stuff and the new school stuff, and maybe the new school is kind of failing a little bit in terms of surfacing and 3D solids. But you can see that you can get some engraving here. The only drawback with this one, though, I found, to be honest, is I'm actually kind of cheating a little bit today because in the HSS toolpath that I used previously to clean up that face, to get that curvature, I actually have a surface offset there, a little bit. Put 10 thou on that face, only because I found that the projection of this engraving toolpath, the translated surface, is a pure projection. I didn't actually have the ability to add any kind of engraving depth. Unless, Kevin, you know how to add that, but I didn't see that anywhere in there to actually add that. This didn't let me do a negative number.
Yeah.
Whereas an HSS projection or your 3D engraving toolpath understands that you're probably trying to engrave. You're probably trying to go into a negative. So, but that's the drawback of this one. And we don't actually see a lot of people using this one, not only because it's not known, but the people that do know about this toolpath, they generally will use HSS. You can do HSS toolpaths a little cleaner, a little quicker. But like I said, if the HSS is not working because of the surface geometry, this is a good alternative. But I see there's some questions popping up, so let's take a look at this. Okay, let me just expand this window here on my side so I can get some clarity on what he's asking. Okay, so so Brian is saying, Brian is talking twice. So the first thing he says is, this doesn't do anything you couldn't do with 3D milling. Correct. With the 3D milling toolpath, you can do very much the same sort of thing. The toolpath might even actually look the same. The 3D milling toolpath is a three-dimensional pocketing toolpath. So it actually will generate those same sort of movements. Maybe not with the curved one. I don't know if you can get that same curvature, but for this one that we did here, basically you will get that same sort of linear step down with the 3D milling toolpath, or 3D machining or 3D HSR.
And kind of like what we were saying with that though is with even the 3D milling, HSS, HSR, HSM, we need a model to go off of. So if we didn't have that model and we're just going off of sketch geometry, this would be another alternative for you.
Yes, yes. So the purpose of the translated surface is that it uses just planar geometry. So it's what you have in front of you. That's another thing I usually say in the training sessions. Use the geometry that you have in front of you. So if you have a solid, then you can ignore the translated surface and use some of those solid-based toolpaths or those surface-based toolpaths. But if you're working from the napkin sketch, you've translated a DWG, a DXF file, and all you have is that geometry in terms of lines and arcs, then you can use the translated surface to achieve a similar toolpath here. And the drawback of this one also is that it needs a path and a cross section. So if that cross section is inconsistent, or you've got multiple paths to follow, either generate a whole bunch of toolpaths or use some sort of recognition toolpath where it does all of it. So this is a very limited toolpath, but yes, you could do very similar things if you had a solid and you had 3D milling. So for Brian's second question, is there a way to remove operations from the milling operations menu, declutter menus? Actually, let me expand this. I already know the answer, but I want to get his entire question on screen here, or on my screen at least. I can't expand this window anymore.
Here, you want me to read it for you?
Declutter the menu of the things I did not buy or does not want don't use ever. Okay, so to do that, when I right click on here, if I scroll all the way to the bottom of this menu, I have the word customize. You'll find the word customize at the bottom of many of our menus, especially I think it's from 2018 or 2019 going forward. When you click on customize, it brings up the window that I cannot bring over. Let's try that again. Okay, so if not, I already showed you guys my other window, so I'll bring that over. Nope, okay, so let's change windows now. Let's go to monitor 2. And if I right click on my other window and go to customize, you see this guy pop up here, and this allows me to uncheck the box next to whatever I don't want to appear in that right click menu. So if you wanted to declutter your window with stuff that you don't actually own or buy, you didn't have license for, you can uncheck those boxes and then it won't appear in your list. So that should help you to declutter your menus.
As well, what you can do too, Brian, is up on the top ribbon, Mark, if you go like the SolidCAM operations, like 2D, we can come up here and customize these as well. And that's actually through the SolidWorks customize ribbon manager. So like you're saying, you don't have, maybe channel synchronization and stuff like that, you can actually remove that out of there as well. And you can build your own custom one if you want to. So,
yep. So any questions on translated surface, on any of the topics we brought up through this week, previous, anything new that you'd like covered, we can cover today, or you can send me an email with your topics, your questions, comments, anything you'd like us to talk about in these classes. Kevin's going to put my email in the chat section. We'll just put it early while we're talking about it, and you guys can send me whatever parts you have, whatever questions you have, any topics you want covered. If you want to review something, we can easily review something because this is SolidCAM Live. We're doing this every day. So chances are, if we missed something the first time around or it wasn't clear the first time around, we can definitely do it again just to get some clarity on it, especially if you have questions on it. Because the whole point of these sessions, of all the sessions, the KevCam, the tips and tricks, SolidCAM Live, any training sessions we do, even the tech support calls. The whole point is to help you guys use the software. So if there's any time you have any kind of question, even if it's a very quick question, don't hesitate to give us a call on the main tech line or send us an email. It's our job to make sure that you enjoy using SolidCAM. So if you get frustrated, that's not my day. I want to make sure that you have a good day using SolidCAM. We have about 8 minutes left. If no one has any other questions, trying to think of what else we could cover today, either with this part or that we haven't talked about yet.
I think we can just end it early if nobody does have any other questions.
You know, we have gone over time a couple of days, so yeah, we built up some time. So, like I said, in the chat section, if Kevin hasn't already put it in, Kevin's going to put my email in there, so you guys can send me your parts, your questions, your comments, anything like that. If you're looking for personalized training, absolutely, we can give that to you as well. It's one of the services we provide. You can use that email to email me with a day and time you'd like to get into a personalized training session. We use GoToMeeting on those training sessions as well. That time around, though, we can take a look at your screen, program your parts from scratch, cover any topics you specifically want covered with some depth. That could be with myself, with Kevin, anyone else on the tech team. We're all the trainers. We can all help you out, even with your really detailed questions. If you know anybody that can benefit from SolidCAM, that as well is something that we would ask that if you know anybody, you can send them contact info for us, or give us their contact info. And if it goes into a demo, you get that $100 gift card. If it goes into sale, then you get a certain percentage of the sale as well. You get that 20% of that overall sale. But like Kevin said, if no one has any questions, we can end it here. Stay safe, keep your family safe, stay busy. We'll talk to you guys tomorrow.
All right, see you guys.